This video is about differentiating inverse trigonometric functions. Now, we've already done this a little bit in our regular A-level maths, but we're going to do it in a little bit more detail. Just a quick reminder, these are the results. You do get given them in the formula booklet, but you also need to show where they come from. So arcsine differentiates to be 1 over the square root of 1 minus x squared. Arccos differentiates to be minus 1 over the square root of 1 minus x squared, and arctan differentiates to be 1 over 1 plus x squared. Just a quick reminder of how to get that. I'm going to demonstrate the first one, arcsine. So, what we do, I'm going to take the sine of both sides, so I can say sine y equals x. I'm then going to differentiate both sides implicitly. So I'm going to differentiate both sides with respect to x. So sine y is going to differentiate to cos y with respect to y, but then I have to multiply that by dy by dx. X, differentiate that, and I just get 1. I'm now going to make dy by dx the subject. And 1 over cos y. I don't want it as a function of y, I want this as a function of x. So let's come back up here. I know that sine y is equal to x. So I know that sine squared y is equal to x squared. I know that 1 minus sine squared y would be 1 minus x squared. Therefore, cos squared y is equal to 1 minus y squared, and so cos y is equal to the square root of 1 minus x squared. There we go. So let's use that same technique on some harder ones. So I want to differentiate arcsine x squared. Now technically I could do this with the chain rule, considering I've just differentiated arcsine on the previous example, but let's practice implicit differentiation a little bit more. So same method as before, sine y equals x squared. Differentiate both sides. So sine y differentiates to be cos y, dy by dx when you differentiate with respect to x. The x squared is going to differentiate to be 2x. Make the dy by dx the subject. And now let's use our identity to try to replace the cos y. So we know that sine squared y would be equal to x to the power 4. So 1 minus sine squared y is going to be the same as 1 minus x to the power 4. So cos squared y is 1 minus x to the power 4. So cos y is the square root. And then we can substitute that in. Next, given that y equals arc sec 2x, show that y equals 1 over x times the root of 4x squared minus 1. So same method, take sec of both sides. So sec y equals 2x. Differentiate both sides with respect to x. So sec y is going to differentiate to be sec y tan y with respect to y. So times by dy by dx. 2x is going to differentiate to be 2. Make dy by dx the subject. Now, the sec y, I already know that that's just 2x. It's the tan y that I need to figure out. Now I know that tan squared plus 1 is sec squared. So let's do some work. Sec squared y is going to equal 4x squared. That's me just squaring both sides here. And like I said, I know that tan squared y plus 1 will equal sec squared. So tan squared y will equal 4x squared minus 1. So tan y equals the square root of 4x squared minus 1. So this is my tan y. I've got the sec y, and I can replace both of them. And that does give me the result that I needed to show. Last example. Given that y equals arctan of 1 minus x over 1 plus x. Take tan of both sides, and we get that. Excuse me. Differentiate both sides. So I'm going to differentiate tan y to give sec squared y. That's it differentiated with respect to y, times it by dy by dx. Now, on the right-hand side here, I'm going to have to use the quotient rule for this. So I'm going to differentiate the numerator and get minus 1. Multiply it by the denominator. Minus. Differentiate the denominator and get 1. Multiply by the numerator. And that's all going to be divided by the denominator squared. So that's me just using the quotient rule on the left-hand side. Let me simplify that. So the whole numerator there is going to simplify just to be minus 2. Like that. Right, so let's divide both sides by the sec squared. Now I need to do something with this sec squared now. Now I know that sec squared is equal to tan squared plus 1. So sec squared y equals tan squared y plus 1. So tan squared y is 1 minus x over 1 plus x all squared. So substituting that now instead of my sec squared here, I'll get 1 over 1 minus x over 1 plus x all squared plus 1 times minus 2 over 1 plus x all squared. Next, in terms of simplifying this, let me just get some more room. So to simplify this, I'm going to I want to deal with this. I don't like this fraction in a fraction now. To deal with that, I'm going to times top and bottom of this fraction by 1 plus x all squared. So on the numerator, I've got 1 plus x all squared. On the denominator, I've just got 1 minus x squared, because this cancelled this. But then I've also got the plus 1 plus x squared there, because of the 1 times that 1 plus x squared. Then I suddenly noticed that actually that's going to cancel with that. And then if I were to expand out the denominator now, so I've got minus 2 over 1 minus 2x plus x squared plus 1 plus 2x plus x squared. The 2x's cancel, and I'm just going to get left with minus 2 over 2 plus 2x squared, or minus 1 over 1 plus x squared. And we're done.